Hi everyone. You probably already noticed that JavaScript is rather important as a web development language nowadays. That's why I decided to make the first module of my JavaScript bootcamp as well as my ES6 bootcamp available for free on this channel. That should give you the very basics or changes with ES6 you will need to, work with JavaScript. If you then want to dive into JavaScript deeper, feel free to take the full courses. I'd be very happy to welcome you there. But if you don't want to, that's fine. These free videos or this free video here should get you started and give you the very basics you need. Before we actually start, let's talk about one very important thing. Where does JavaScript actually run? Now you might know this, in this case just feel free to skip ahead. But if you're not 100% sure about this, here you go. JavaScript typically runs in the browser, which means when you load a web page, JavaScript is not executed on the server from which the web page comes, but instead in your browser. That's why JavaScript is so popular these days, because it allows you to create very good and reactive user experiences, since it doesn't depend on some kind of server responding in time, but it runs in the browser, there where the user is using it. There is no closer way or no closer place to execute code, and therefore JavaScript is very powerful. But there also is the chance to run it on the server with Node.js, which is a server-side language based on JavaScript. Now in this course, I'll clearly focus on the browser part, but many of the concepts you learn here, indeed all of the very basics of JavaScript and how it works, will of course also apply to the server in Node.js. Node.js extends the language and offers other features as well, but the core language, of course, is JavaScript, and therefore the things you learn in this course are relevant for this as well. Before we actually get started with the course, let's talk about ES5 versus ES6, or let's talk what ES5 and ES6 means to begin with. ES stands for ECMAScript. And now you might be confused because a few seconds ago I was talking about JavaScript. Now what's ECMAScript? ECMAScript kind of is the overarching language which has its own, committee, if you want to put it like this, which develops the language, implements new features, or at least, decides which new features should be implemented in the next version, and so on. And JavaScript therefore is kind of a dialect of ECMAScript, though you think you can safely say it's the most important one, and therefore the two terms are often used interchangeably. And as a dialect, it follows the specifications of ECMAScript. So when I talk about ES5 and ES6, I talk about versions of this language, and currently ES5 is the most recent version, which means it's supported by all major browsers, even for a bit older versions of those browsers. ES6 will be the next big thing. It will be the next version of JavaScript, if you want to put it like this, and it implements many cool features. And indeed, you can check out my ES6 bootcamp to learn about those new features. However, ES6 is not supported by all browsers yet, and oftentimes you'll need some polyfills or transpilers which actually transpile your code back to ES5 versions, which then would work again. So it's not natively supported, and therefore in this course I'm focusing on ES5, the code which will actually run for sure, and you may check out my ES6 bootcamp for all the new cool features which you will be able to use in the future. This course follows a special approach. I believe that you learn the most if I'm able to focus on one part of the language at a time. Now, oftentimes you see courses where you learn certain features, but you want to implement them in a web page, and therefore you need to write some other code which is not really connected to the topic you want to focus on right now. I think that's a problem because it deters you from really deeply diving into the topic at hand. Therefore, the format I chose for this course is the following. We'll be using a web page named jsbin.com. So if you navigate over there in your browser, you see that it should look something like this. Now it might look a bit different if you open up for the first time. You might close this thick blue thing you got at the top when opening it for the first time, and then make sure to only check JavaScript and console here so that only these two items are highlighted. Now from time to time I'll also use some HTML code and possibly the output, but what this page allows you to do basically is to write a simple JavaScript HTML program and see it run immediately. Therefore, we don't have any problems with setting up our workspace or having to write redundant code, which isn't really the topic at hand. That being said, of course, I have a separate module about setting up a workflow and setting up a real project, because in the end, of course, you won't be writing applications in this tool. But it's great for learning, and that's why I'm using it. For the majority of the course, we won't even see the HTML code. We'll just use JavaScript and see what happens in the JavaScript console, which is a convenient way to output values. Now you might argue, well, my programs won't output it to the console. I need knowledge how to work with HTML code. And you would be right, but that is why I have a complete module, or two actually, about interacting with the HTML document. But it's very important to understand all the other parts of the language first, and for that you won't need HTML, since it's only one part of the language and it's only about, well, actually displaying it in the HTML code, but not the logic you write. The logic you write depends on functions, objects and data types, and that can be perfectly output in the console like this. So for example, you'll see me type something like assigning a variable, and of course I'll come back to variables very soon, and then logging that variable to, well, the console log. And if you then hit Command Enter here, or click this Run button, you see that it gets executed and gets printed to the console on the right, which is a very convenient way to see what actually happened and what the result of a certain calculation might be. Welcome to this basics module. In this module, we'll have a look at the, well, very basics of JavaScript, how the language works, and what are the key parts of the language which allow you to write awesome applications. We'll have a look at how JavaScript is actually executed and how you can implement it in your web page. Then we'll have a look at what variables are and how we can use them, which types JavaScript knows, what functions are and how functions work. We'll have a look at control structures such as if or loops, and finally at some operators you can use for, well, during your program for calculations or for comparisons. So let's start with the very first important step. Even though we're able to execute it here simply, well, typing code on the left and seeing it in the console on the right, technically, you would need to implement your code in your HTML document to have anything to run. So if I open up my HTML document here, you see this is our normal HTML5 skeleton, and I won't go into HTML basics in this course. I will create a new header here, and you can quickly do this by simply typing H1 and then hitting tab, or just say the JavaScript bootcamp. Now this will appear in the output here, but we won't need the output for now, so I'll close it. Let's see, how can we execute code in such a HTML document? Well, if I go below the title here, I can type script and hit tab, and this will create script tags for me. If I type console log hello there and close this with brackets or with parentheses here, and then I click run, you see hello there in the console, even though I didn't write anything here in the middle, right? Well, the reason for this is this middle column here is just a service or a convenience offered by this website where I can execute JavaScript right away, and indeed we will heavily use this throughout the course. But in reality, you will have to include your scripts like this with such a script tag in your HTML document. Now, when the browser renders your page, it basically runs through your HTML code from top to bottom. And when it hits this script code, it will immediately execute all the code it finds between the opening and closing tag here. This is why hello there gets printed to the console, because that's all the code I have here. And as I said, it's immediately executed. Now the script tag also has some attributes you can specify. For example, the type attribute. I can set this type here to text/JavaScript. And if I click run, what will happen? I still see hello there. Because this is an optional attribute, I can pass to specify, well, that this is indeed JavaScript code, but I may also leave it out, and indeed you would leave it out typically. So there is no difference between both ways of executing this code. Notice that currently I'm executing this code, or I have the script tag right here in the head section. Now imagine I take this code here, remove it from the head section, and put it right before my closing body tag here, so at the end of the body section. What do you think will happen now? Well, if I click run, we still see hello there, because as I said, the browser runs over your file from top to bottom and will execute any JavaScript code it finds. Therefore, the position of the code doesn't really matter. It doesn't have to be inside the head section to be executed. Indeed, it's best practice to put it right here where it currently is, right before the closing body tag. Why is this the best practice? Well, as I said, the browser goes from top to bottom through your file and builds up your web page. Now imagine you have a JavaScript code here which triggers some long-running operation. In this case, the browser would be occupied and couldn't continue loading your web page below this script tag here. Now that would of course mean that you might not see your web page, even though technically it could be loaded even with your script not being finished. Therefore, by putting your scripts at the end of the page, you make sure that the HTML document actually gets loaded before the script is executed, which of course first results in a performance increase, and second, it makes sure that if your script is trying to access some HTML elements in your page, those elements are actually there because the browser already ran over the specific code. Now, as you might be aware, you also have the chance of turning off JavaScript in your browser. How can you handle this case that a user visits your page which has JavaScript turned off? Well, that of course depends on your page. If your page depends heavily on JavaScript, you might just want to show him a message telling him that, well, he should turn off JavaScript or, well, leave the page because you're not able to provide a well-browsing experience. In other cases, it might not really matter. But if you want to display such a message or any message, you can use the no script tags with any message between them, and this message here will only be displayed, of course, in the normal page here, not in any console, in the normal page, if a user visits the page with JavaScript being turned off. So until now we had a look at how we could place JavaScript code in our HTML document and execute it. Now imagine you have a more complex application with a lot more code than one single line like we currently do. In this case, it would not be that great if all of that code would be in your HTML document. Why wouldn't that be great? Well, first of all, because it would be very hard for you yourself as the developer to work with that big file of JavaScript code. Therefore, it's very common and indeed best practice, of course, to actually outsource your JavaScript code in separate files, which you then import into your HTML document, so that you don't have the JavaScript code in the HTML document itself. An easy way to outsource this is to simply import another file where you hold your code. Now, unfortunately, I can't really demonstrate this here with JSBin. Therefore, for this example, we're heading to another page, plunker without an u.co, which is kind of a similar tool, but follows a different approach in some places. And here, as you can see, it looks a bit similar here, but it doesn't have that extra console. Indeed, here instead, we just see the web page here being loaded. Here, you can already see we got such an import here. And we're importing, as it looks like this, script.js file. Now, as you see, for the import, We still use script tags, and notice that we have an opening and closing tag even though there is no code between the tags. And we have this source or src attribute on the opening script tag where we specify the path to the file we want to import, script.js in this case. Now script.js can hold any code we might want to have. So if I enter console log hello there here, what do you think we'll see in the console? Well, first we need to have a console to begin with. So I'll open my developer tools here in Chrome, which I can do with hitting Command, Alt, and then I, or Control, Alt, and I on Windows. Or of course open them from the menu by going to View, Developer, Developer Tools, or just the JavaScript console here. And there you can see we also got this hello there text, even though of course in the index.html file we don't have that hello there anywhere, but we're importing this file, which again will be executed immediately. So the behavior does not change. If you have code in an external file, this code will be executed as soon as JavaScript finds this file. And therefore it's really just a way to restructure your code and get rid of the code in your HTML file. Now, of course, you might not only import this in the head section, but in the body section as well, which, as it was before, is a good practice to make sure that your code actually gets executed last. As you see, we have this opening and closing tag and nothing between. Can't we just write this? Well, let's test this. I clear my console here and make this a bit bigger. And let's see what happens if I click this refresh button. Nothing happens. We don't see hello there. So the code is not getting executed. And the reason for this is that the script tag always has to have an opening and closing tag. That's kind of a historic thing that it, well, used to be written like this with code between the opening and closing tag. And it's still the case. As you see, it now prints again, and we have to provide the opening and closing tag when referencing external files, even though there is no code between the two tags. That being said, what does happen if we put code between the opening and closing tag? So let's say I write hello from between here, and I save this. Well, as you see, we still only got hello there here. We're not seeing hello from between, even though it has a typo. So why is this the case? Why don't we see this code being executed? Because the browser won't do that. The browser sees that we import a file here, and therefore it will still execute that file. It doesn't care what we write between the opening and closing tags. It will indeed just ignore everything between the opening and closing tag and only execute the code in the imported file. So this code would only run if you would get rid of the import here, like this. Now you see we're getting hello from between. So I'll get back to importing from script.js and I'll get rid of this code between the opening and closing tag. Now, can we also import multiple files? Let's try it. I'm going to copy this import and I'll name this file script2. Now, as you see, I'm currently getting an error that there is no script2.js file. And if I click on new file here and create the script2.js file, and in here I write console log script2, and I save this, you see we get hello there and script2. And I'll clear my console to see this a bit better. Hello there and script2. So both scripts are getting executed, and they get executed in the order we specify the imports here. That of course is important. If you have one file depending on the other code being run, then you need to put the file depending on that after the first file, otherwise this code would not be executed yet. So this ordering here is pretty clear and pretty important. Also, oftentimes you might use third-party libraries like, for example, jQuery. And if you want to use functions from jQuery, you have to make sure that the jQuery import comes first before you import your code depending on it. Now you can change this behavior. There is another attribute you can use. I can put the defer attribute on this first script here. And as you see now, script 2 gets executed first before hello there. So defer basically tells the browser, wait with this script and only load it after all the other scripts which don't have defer on them were executed. Now you can use this, but honestly, it's really better to just change the ordering because that is just confusing. And if you're working together with other developers or you yourself forget that you put defer on such an import, you might be wondering why this isn't working the way it should. And therefore, well, I would strongly recommend not using defer and instead just placing the imports in the order they should be placed. So now that you know how to run the code, how to embed it in your HTML document and use it there, let's actually dive into JavaScript itself, into the fundamentals of the language and how it works. I'll start with the fundamental thing existing, variables. Variables are a very, very basic thing in each language, and without them probably no code would work. So what are variables? Variables basically are little data structures or storages which allow you to store values, to store data if you want to put it like this. You create a variable in JavaScript by using the var keyword and then give this a name following the var keyword like variable. And there are some reserved names, but most of the names are free and you will get errors if you try to use reserved names. And then you assign a value by typing equals and then the value you want to assign. For example, 5. Now what's the benefit of doing this? I can use this variable throughout my code. So for example, I can use console log and write variable here. And now if I hit Command Enter, you see 5 in the console, which of course happens because we're printing the value of the variable by using the variable here in this function. I'll come back to functions in a later point, of course, too. So variables are places to store data. This, of course, throws the question, which data can be stored? Here you see a number, 5. Notice that we just typed a number like this. Imagine I wanted to store some text. Let's say text. What do you think will happen? What will I see in the console if I click run? I get an error. The text is not defined. Because by using text or characters like this, JavaScript expects this to be a variable, like we defined variable here. This also is just some text we entered here. So JavaScript would expect a variable of name text to be set equal to variable. And of course we don't have such a variable here. We didn't initialize a variable named text. So this won't work. If we want to print actual text, so a string of characters here in the console, we would have to put quotation marks around text. If I now clear the console and click run again, you see that we print text here instead, so the real text we wanted to print. And this of course is important to know and understand, that if you don't have quotation marks and it's not a number, JavaScript expects a variable with this name, or a function or something like that. And therefore we would get an error if this variable doesn't exist. So we saw numbers and now we see text. Which other types do we have? Well, we also have booleans, which means true or false. And we can easily set this like this, true. Now wait a second. A minute ago I said that you have to put quotation marks around text if you want to use it, and that now JavaScript would look for a variable named true. Theoretically yes, practically no. I also said that there are some keywords which are reserved and can't be used for variable names. True is such a keyword. And therefore, true here will not resolve to a variable, or JavaScript won't look for a variable named true. Instead, true is a value, like 5 is a value. And if I clear this, what do you think we'll see in the console? We see true. Notice that we don't have any quotation marks here or something like this, because true is a value, like 5 is a number, or the text you saw a few seconds ago was a string. This is a boolean, and this is its own data type we can use. And of course, we not only have true, we also have false. Now, with all that being explained, would it work if I rename variable to my number 1 var like this, 1 var? No, this won't work. I must not have a number at the beginning of a variable name. That will not work. I may have a number in my variable name, but not at the beginning of it. And var is also a reserved keyword, though var1 would work, because now I have a new variable name. It's not just var, and the number is not at the beginning. Therefore, if I clear this and hit run, this would work, since now we're again having a valid variable name. But back to the basic types we have. We saw a number, text, and boolean. What about the following? If I have 6.5 here, what do you think I'll see in the console? Well, I see 6.5, but the question is, what is this? Is this also a number, or is it a float like in some other languages? Was the first number 5 an integer? Because if you're coming from another programming language, you might know the concept of having integers and floating point numbers, and there is a difference between both. Well, let's see what this is. We can not only print the value, we can also print type of. And if I print this, well, we see this is of type number. Now, since we're at it, let's see what 5 is. It's also a number. So a floating point number like 6.5 and 5 both have the same type. JavaScript doesn't know integers and floating point numbers. It's all just a number. And by the way, since I didn't check this earlier, what was the type of text? String. So this is of type string. And just to finish the line here, if I check true, you see this is boolean, as I explained. So we had a look at the very basic data structures: numbers, strings, booleans. But JavaScript offers us more data structures than these. Let's have a look at the following. If I have squared brackets, and then 1, 2, and 3. What do you think I'll see in the console if I hit run now? Well, I get it printed like this. But what is this? Well, let's check it with type of. It's an object. But actually, yes, it's an object, but specifically it's an array. An array is a collection of values. And this clearly is a collection of numbers here. So we have 3 numbers in this array. And the cool thing about an array is that it allows us to store multiple values in one variable. As you see here, we have 3 numbers in one variable. We also may mix different data types. So I may add 4, but notice that 4 is in quotation marks. So 4 actually is a string here. So if I run this, you see we still get it printed out, but now we have an array of mixed data types, which might have its uses in your program too. Now, while it's certainly cool to have such a collection, you most of the time won't need the complete collection, but you want to store several values there, but then want to be able to access the different values. You can easily access values by putting squared brackets after your variable name when you're accessing it. And between the squared brackets, you put the index of the value you want to access. Now here's an important thing, and I will come back to arrays in a later stage of this course. Arrays start with an index of 0. So the first element, 1 here, has an index of 0. So if I try this, accessing the first element as you might think, what do you think I'll see in the console here? 2. So we're actually accessing the second element, even though I typed 1 here. And the reason, of course, is that the first index actually is 0. So if I hit run now you see we're getting 1. And that's just important to keep in mind. Therefore, the last element is not 4. And if I were to try accessing the fourth index here, or index 4 here, what do you think we'll see in the console? Well, we're not seeing 4, but we're getting undefined. And undefined is a pretty clear message. We're accessing a value which is not defined. We're accessing the last index here, and you can think of this like having an extra comma here. So now here we have a new element, but there's nothing there. So what do you think shows in the console if I now click run? Still undefined, because now I just made clear what happened before. We have this extra element, but there's nothing here, so it's undefined. Now we also got some other types we can use. This is an array here. If I get rid of it and instead try this, undefined. That was what we just got a couple of times, right? What do you think I'll see if I now hit run? Well, we still get undefined, so we can set a variable to being undefined, but we should not do this, because undefined really is JavaScript's error message of telling us, hey, you're accessing something which isn't there, which wasn't defined. And if we want to set a variable to being empty, and there are cases where we want to do this, where we want to reset it, where we want to clear it, we should not use undefined, but instead null, which also is a keyword and tells JavaScript, hey, this variable is now not set, or it is empty, but it is not undefined. So what do you think I'll see in the console if I now hit run? I get null, because now it is set to null and not to undefined. Now, is null the same as undefined? Let's check this, and I'll use an operator which I'll explain in more depth later on, but basically I'll compare null to undefined, and I'm printing the result of this comparison. Now I'm comparing it with two equal signs, which means check if the value is equal. And what do you think I'll see in the console? I get true. So internally, JavaScript has the same value for null and undefined, which means it's kind of the same if we only have a look at the value. But if I add another equal sign here, I not only check for the values being equal, but also for the types being equal. And if I now run this code, I get false. So null is not exactly the same as undefined, but value-wise, it's handled in the same way. So we had undefined and null. We have one other special type. I'm going back to printing out the variable, and I can also set it to capital N, lowercase a, capital N. And that refers to not a number. Not a number, as the name says, is, well, simply just not a number. And what do you think I'll get when I hit run now? Well, I get not a number. But what's the sense of this type? Well, typically you won't set a variable equal to not a number, but you might get not a number as the result of some kind of mathematical calculation. If something goes wrong there, or for example you try to multiply a number with a string, which doesn't work since you can't multiply these two types, then you would get not a number as the result, since the result isn't a number, since JavaScript isn't able to get a result. So it's mostly an error message from mathematical equations or mathematical operations. Now with null, undefined and not a number, What is the type of not a number? What do you think we'll see in the console? It's actually a number, which is pretty confusing since it's called not a number, right? But as I said, it's the result of a mathematical calculation, and therefore technically it's a number, but it's a special number, a kind of undefined number if you want to put it like this. So actually a number which isn't a number. And yes, this is a bit confusing, but basically think of it as an error message from a mathematical calculation. And whilst we're at it, what is the type of null? What do you think we'll see if I hit run? It's an object. And what's the type of undefined? It's undefined. So this is why I was getting this error when comparing both with 3 equal signs, which also checks on type equality. The types of undefined and null are not equal. Undefined is of type undefined and null is of type object. The values are equal. And that's important to understand here. Now I'll go back to printing out the variable and I want to show another, and for now the last, very important value or data structure in JavaScript, an object. And I'll have a complete module on objects in this course, but I want to get started with it right now since we're talking about variables in general and which values you can assign to variables. Well, an object is such a value. One of the quickest ways to create an object in JavaScript is to use curly braces, and then you may expand this to over multiple lines. This will work. And here you can create fields and methods. Now, fields are basically variables inside an object, if you want to put it like this, also referred to as properties. And methods are functions inside variables. And no worries, I'll come back to both things soon. So I could specify name here, and now I'm not assigning a value with an equal sign, but inside of an object, indicated by the curly braces here, I assign it by typing colon and then the value, for example, max, which is a string here, of course. Now, what do you think I'll see if I print var1 to the console? Well, I see object, and then the actual object. So I see the object I just created. But the cool thing about objects is I can also access this name directly by typing dot and then name. So the name of this field, which happens to be name here. If I now click run, we see max, so it is string. So now I'm kind of accessing a variable, even though you would call it property or field, inside my object here. And objects are very important data structures, since you may have multiple fields or nested fields and functions inside them, so you can kind of group different functionalities, and well, you will work with objects quite a lot in your code, and we will see objects quite a lot throughout this course as well. So what is the type of this object? If I run type of, and now I hit run, it's object. So that probably wasn't too surprising, but as I just explained, this is an object and it's of type object, of course, therefore. So I'll change this to a better code style as well. And now let's have a look at something else. We have var1, which is 5. What happens if I also create var1, set this equal to 10, whoops, add a 1, but notice that I have a capital V at the beginning. If I now copy this line here and also print var1, what do you think I'll see in the console if I hit run? Well, we get 5 and 10 because These two variables are two different variables, so JavaScript is case sensitive. We have two different variables even though it's the same name, but the capital V does matter and actually creates a new variable. Therefore, two different values are printed to the console here. Now what happens if I have var1 here? I'll get rid of the second variable here, and I'll also won't print out it anymore. But now after printing it out, I'm setting var1 equal to 10, and then I print it out again. What do you think I'll now see in the console? 5 and 10, because now here I'm reassigning the variable. Notice that I don't have the var keyword here, and I don't need it, because I'm not creating a new variable. Var is only needed when creating a new variable, so for declaring a variable, but instead I'm using an existing one and I'm reassigning it here. Therefore I'm changing the value, and that is how you can do this. And this of course is also something you'll probably do in your code, that your variables might not keep their initial value, but instead might receive new values throughout your code. What do you think will happen if I turn this 10 here into a string by adding quotation marks? What do you think we'll now see in the console? Well, we see 5 and then a string of 10. So even though the variable was a number at the beginning, we can change it to a string. And indeed we can see this type switch if we print the types instead of the values. So if I now hit run, you see that we get number and string. So the type of the variable was actually changed, because JavaScript uses dynamic typing, which means variables may change their types. That is something most languages or many languages don't offer. There you would create a variable of type integer, and then you would only be allowed to assign integers or strings or whatever the type is of the variable to that variable. In JavaScript, it doesn't care. Therefore, you're not telling it which type this variable should be, you just set it to an initial value and then it has the type of this value, but it has no problems of switching the type later on. This might be useful in some situations, but generally it's also a good practice to not do this, to not switch types constantly, but instead stick to the initial type. What is a function? A function basically is some kind of enclosed code which you can execute whenever you want, even multiple times. So remember that before, whichever code we put here was executed immediately by the browser. Whenever the browser finds this code, be that in an imported file or directly in the index.html file, it will directly execute the code. Now we can create a function like this with the function keyword and then the name of the function. Let's name it calc, for calculate maybe. Then you have parentheses and then curly braces. And now don't mistake these curly braces with the ones we were using when creating an object. Curly braces generally just mean we're creating kind of a block here which belongs together, so we can have multi-line statements in here which all belong to this block. That's all we do with these curly braces. So inside these curly braces we might write the logic this function should execute. So I'll again write console log inside function here. Now what do you think will happen if I click run? Nothing, because even though the code gets executed instantly, functions don't get called automatically. That is not really what functions are good for. Instead, we have to call them like this, using their name and then with parentheses here. Now if I click run, you see inside function, because now the function gets executed. Does it also get executed if I leave out the parentheses here? No, nothing happens. So the parentheses here are important to actually call a function. And as you'll later see, we can also do more with these parentheses than just define and call it. An interesting thing is you can also use a function if you define it after calling it. So if I hit run now, you still see inside function. And here again we have hoisting. Now with functions, unlike with variables, it's not that uncommon to have function definitions like this one here after the usage. So that is a fine behavior. And you might actually use this in your code as well. Now I'll put it back to the top anyways. And I want to show you another way of creating such a function. So you can use the function keyword and then the name here. But another way to do exactly the same would be to create a variable, name it calc, and assign it to a function. But notice that now here we don't have a name, we just have function and then parentheses. So now if I run this, what do you think we'll see? We still see inside function, but we also should now put a semicolon here. Because now we're technically creating a variable and we're assigning this function to this variable. We can then still call the function with, well, calc and then parentheses. So that doesn't change. It's just a different type of creating a function, but we may use both types. Now speaking of this, what do you think we'll see if I log the type of this function? And notice that I don't have parentheses here. So I'm not executing the function. I just want to refer to this function variable. So if I hit run now, we see function. So this is of type function. And it's the same true if I use the other way to create a function. What do you think we'll see now? This is also of type function. So it is the same. And it has this special function type in JavaScript. So it's a variable of type function here. Now, can I do the following? Create another function and assign the first function to it, but without parentheses here. And then I try to execute another function, which should be this function here, right? I assigned this function to this variable. So if I now hit run, what do you think we'll see? Well, we'll see inside function because this works exactly in this way. We're creating a new variable and we're just assigning it another variable. And this variable happens to be a function. Now what happens if I use parentheses here? What do you think we'll now see if I hit run? Well, now we get inside function, but then we get an error. And the reason is we get inside function here because we're executing the function here. But then we're trying to assign the return value to this new variable. Now this function doesn't return anything, it just executes some code. Therefore, another function is now not set to this, and therefore we correctly get the error that another function is not a function. So we can't execute it. So what is another function? If we log out another function here, it's undefined because we're setting it to something which isn't there. We're setting it to the return value of this function, and as I said, this function doesn't return anything, therefore we're returning nothing, therefore it's undefined, and that's why we could not execute it like a function. So what is this return value I'm talking of? Well, let's say I change this here to not print something out, but instead I want to return a string. And this is a common scheme because oftentimes your functions will just do something and return a value for the caller of the function to use. I can return a value by adding the return keyword. So now I'm just returning a string. This is no variable assigned to a string or anything, it's just a string. So I'm returning this string here, and then I'm assigning this returned value to another function, which now isn't a function, so maybe I should name it returned to make this less confusing. So returned is now what this function, calc, returns, which again is this string. So now if I print returned, what do you think we'll see? Well, of course we see inside function, because now I'm printing what this function returned to me, which is this string. Of course, I could also return a variable defined inside calc. So return string var. What do you think we'll see now? We still get inside function because I haven't really changed anything. I'm just using a variable inside this function, which is perfectly fine, and I may do that. Now, there is something special about the scope of this variable, but I'll come back to this in one of the next lessons. So I'm now returning stuff inside this function, and that's cool. But sometimes I also want to pass something into a function and not just return values. I can do this by adding arguments here between the parentheses in my function definition. So maybe, since this function is called calc, I want to calculate something. So I'll pass two numbers, let's say, number 1 and number 2. Now here, I'm not assigning any string variable, but instead I want to return, let's say, the addition of number 1 and number 2. And this is just the addition operator here, of course. So now, if I execute this, what do you think we'll see? Well, this might not have been straightforward, but we get not a number. The reason is we're still calling this function without passing any arguments here, right? But we try to add the arguments we get and we return the result. Now, we did not get an error, which would be the case in some other languages, because we're calling a function which expects arguments by not passing arguments. But what gets passed indirectly are two undefined numbers. So technically we were adding undefined plus undefined, which will, since we're doing a mathematical operation here, result in an error and return not a number, because we can't add undefined and undefined. Therefore, we are returning this result, which is not a number, and then we're printing it. This is why we see not a number here. So to make this function call here more useful and not get not a number, I will add arguments to it, let's say 10 and 8. And I do this by simply specifying them here when I call the function separated with commas. If I now run this, what do you think we'll see? Well, we get 18 because we're adding 10 and 8 inside this function and returning the value, which we then print here. So now this works. What happens if I pass too many arguments? So if I pass one extra 10 here, what do you think we'll see now? Well, we still get 18 and the other argument is just ignored. We don't get an error like we would get in other languages, but it's not getting used either. And now what do you think happens if I change this a bit, and here I create my variable named calculator and assign this to this calc function, but I'm not executing the function here. And then I log out calculator 15 and 2. What do you think we'll now get in the console here? Well, we get 17, because what I'm doing here is I'm just assigning this function here to a new variable. So this variable is now also pointing to this function. And then I'm executing this function and I pass two arguments. And therefore I get back the addition of the two arguments, since I'm simply just executing this function here. So that were the basics about functions and how you can use functions. Now, why would you use such functions? Well, as you already saw, functions allow you to enclose some code, and you can of course call functions more than once. Therefore, it's a useful utility for repetitive tasks or more complex calculations or code you don't want to execute right at startup, because remember, generally all your code will be executed once the browser runs through it. Now, I was speaking about the browser executing the code immediately at the end of the last lecture. You can control the flow of the code execution with control structures. Control structures basically allow you to tell the browser when to execute certain code or execute certain code more often than once. So really useful tools you have in your toolbox for creating awesome applications. A very common and wide known control structure is the if statement, which basically allows you to run some code conditionally. So I'll create a new variable and I'll name it condition, and I will set it to true. So this is a Boolean variable here. And then I'll create an if statement by writing if and then a condition between parentheses here. Now, as you'll later see when I come to operators, you can also compare certain values here. But here I'll just check if condition. And with condition, of course, I'm referring to this variable here. Now, an if statement, which I then create by adding curly braces, expects true or false. These are the only two values with which an if statement can work, because it's checking if this is true, then execute whatever is between these parentheses or these curly braces, excuse me. If this is false, the code between here will not get executed. So if I now log something here, for example, executed, well, I think this is pretty straightforward, but what will we see if I hit run? Well, we see executed because I'm checking if condition is true, and of course condition is true because I'm setting it here. And on the other hand, of course, if I set this to false and I hit run, we see nothing because this code is now not executed. Sometimes we also want to check if something is true, but we want to provide or execute some other code if, well, the condition is not met. We can therefore add the else keyword and then curly braces after it again. So now we execute this code if the condition is true. But if the condition is not true, so if it is false, we'll reach this code here. So what do you think we'll now see if I hit run? Well, we still see executed because it's still set to true. But if I change this to false and hit run again, you now see we get not executed because now we're reaching this else part here. There's also another thing we could specify, else if. Now, why would you specify else if we only can handle true or false? Well, sometimes we want to check multiple conditions for being true. So for example, here we check if condition is true and then we print this code. But if condition is false, we want to check if another condition is true. And if another condition is true, and we check this here, we execute this code, and if this would be false too, then we would log not executed. So now we're first checking if this condition is true, and if this is the case, we will execute this. But if this is not the case, we'll check if at least this condition is true, in which case we would execute this code. And if all of that is not true, well, then we reach the else part here. So what do you think we'll see now? Well, we get still executed because we're not meeting the first condition since this is false, but we do meet the second condition since this is true. Therefore, we get still executed. If I set this to false, we'll get not executed. So we're in the else part then. So we had a look at the if statement. Another control structure based on the condition or the values of certain variables is the switch statement. I'll create a new variable which I call lucky number, and I set this equal to 8. Now I create a switch statement by typing switch and then in parentheses the value or the variable on which I want to switch, so lucky number here. Then I also have curly braces, and inside of these curly braces I now define several cases I want to handle. So generally with the switch statement I look at a variable And then I decide what to do upon certain values this variable might have. So for example, I might have the case that a variable is 1, and I do this like this: case, and then the value I want to handle, and then a colon. Then I enter a new line, and I don't need curly braces here. And I write, for example, console log is 1. And then I have to type break. I'll come back to this keyword soon. I also want to handle the case that it is 8, for example. And then I will log is 8. Also break here. And then I have a special case here, the default case, which I specify with the default keyword. This code here is executed whenever this value, in this case here, is something else than 1 or 8. So I'll print default then. And also break here. What do you think we'll see if I hit run? Well, we get is 8, because we're switching this number and we're handling the case that it is 8. What do you think we'll see if I change this to 7? Well, we get default, because we're only handling the cases that it's 1 or 8. In all other cases, we will run this default code here. So with the switch statement, we have an easy way to execute conditional code depending on the value of something. And this could also be written as an if statement, where we check if lucky number equals 1, and then we would print this, and then we would have else if lucky number equals 8, and then we would execute this code, and then we would have else, and then we would print default here. And this would do the same as this statement. And in this case, this might even look shorter. But imagine us handling multiple cases. This here is much more structured. Whereas here we have to write all these else if statements, which quickly becomes very inconvenient. And that is why we have this switch statement, to make such cases easier. Now, what's up with this break keyword here? Well, I best show it by leaving it out. So I'll remove break in all these places. And what do you think we'll now see if I execute this with a number of 1, for example? Well, we get all 3 values, because now the value falls through. This is how it's called. It reaches this point because we have a case of 1, but then it just continues execution from top to bottom, like JavaScript code is executed. So it's not considering that we have case here and that this would be a different case. It's just executing all the code and basically ignoring this case 8 and default thing here. So if I enter 8, what do you think we'll now see? Well, we got is 8 in default. Maybe you were expecting to also see is 1, but it's still checking which case is the case, so 8 here. But then it continues executing to the bottom. It's not doing it right from the beginning, just we don't have breaks here. But once it found its case, it will continue and not stop. So by adding break, we're basically telling JavaScript that we wanted to finish execution at this point and not continue with the next lines here. So we break out of the conditional, so to say. So we had a look at conditionals, so control structures, which allowed us to change the flow of code execution based on certain conditions being true or false. Another important control structure are loops, which allow us to execute code multiple times, so more than once. I'll have a look at the for loop first, and you might know this loop from other languages, of course. A for loop is created like this. We use the for keyword and then we have parentheses. Here we set up a variable which will be used inside this loop, typically I, and we set it to an initial value, for example 0, which is a common case. Then we have a semicolon, and then we specify the condition which defines how long the loop should be running. For example, that I, the variable we just set up here, should be smaller than 5. So this loop will execute as long as I is smaller than 5. Again, we have a semicolon, and then we specify what we want to do with I upon each iteration. Here, I want to increment it by 1, and we can use the increment operator for this by simply adding 2 plus signs right after I, which of course is the variable name. This will count up I by 1 upon each code execution or each loop round here. So whenever we start a new round in this loop, or whenever we finish a round to be precise, we will count up I by 1, so add 1 to it. Then I have curly braces again to define the code which should get executed inside this loop, and I will just print out I, so this variable here. What do you think we'll see if I hit run? Well, we see 0, 1, 2, 3, and 4. So we're not seeing 5, but as you can see, we executed it 5 times and we started at 0, which is the initial value. So technically what happened here is that we set I to 0, print it out, add 1 to it, because that is what we do upon each time we finish one round of this loop, and we finish the round after this code line since we have no additional code coming. And then we got I equal to 1. So we continue since it is still smaller than 5. And we continue as long until it is 4. Then we print out this value a last time, 4. And then we add 1 to it again. Now it's 5, and therefore this condition is no longer satisfied. I is not smaller than 5 anymore, and therefore this loop is now quit, or we exit out of this loop. This is why we print 1 to 4 here. Now an important thing to realize is you're not only able to set I equal to 0, you of course may also start with 2 and then only got 2, 3, 4. You also can specify other conditions here like greater or smaller equal, anything like that, and I will come back to comparison operators soon. And you can also not say that you want to add something to it. You could also say that it should be set equal to I plus 3, for example. What would happen now? We only get 2, because after the first iteration, where I is 2, we add 3, so we get 5, and this condition is no longer satisfied. We also can subtract this value or decrement it. So now we're subtracting 1 from I upon each iteration. But if I now hit run, we would have a problem, because this would be an infinite loop. We have I equal to, we subtract 1 upon each round, and our exit condition is that I gets bigger than 5, or our continue condition is that I is smaller than 5. Now this loop would never get exited, because since we decrement I, we would always be smaller than 5. So here we should change this and say only keep this running as long as I is bigger than 1, for example. If I now hit run, we only see 2, so we only make 1 round because we start with 2, subtract 1, and we are 1, so this is no longer satisfied. This is how you can play around with loops and how you can set the variable here, I, and of course you could use another name as well, up the way you want it and need it for your program to work correctly. Now, a common thing to use such loops for is to use them in conjunction with arrays. Remember, an array, I'll just create a variable here, looks like this with brackets and contains multiple values. Now, since we have multiple values in one place, I think it's one of the first things you think about, that you could loop through that and use these values step by step or value for value. You could do that by setting I back to 0 and going back to incrementing. I'll also change this to being smaller than something, but the something, well, it could now be hard-coded 3, and I could then log array and access the index with, well, the variable I, which of course gets increased up on each round. So now if I hit run, what will we see? Well, we see 1, 2, 3 because I'm now step by step accessing the value in the array. But that's not really the best way because I hard coded the size of the array here. If I change this to 5 because I expect the array to have 5 elements, but it actually only has 3, what would I now get? Well, I get undefined because I'm accessing values which aren't there. So that's not really good because rarely can I know how big an array is. And even if I could know it because I hard coded it, I might change this later on and then I would have to change the size in all places in my code where I hard coded it. So a better way is to use my array and access the length property on that array. Because remember, an array is an object and it happens to have this length property built in. And as this name implies, this gives me the length of the array. So now I'm looping as long as I is smaller than the length of the array. What do you think will happen if I now hit run? Well, you get 1, 2, 3 again, because the length is of course 3. Notice that it is important to understand that since the first index of the array is 0, we have to use the smaller sign then, and not smaller or equal. Because in this case, we would loop until I takes a value of 3, which actually tries to access the 4th element. And that is not the behavior we would like to have. So this is how we would write it to loop through such an array. So we had a look at the for loop, but there's another loop built in. Actually, there are 2 other loops, but one loop is something I'll have a look at when we talk about objects. The other loop I want to talk about right now is the while loop. The while loop works like this. I set a variable, let's say number, equal to 5. And then I want to create a while loop with the while keyword and then parentheses. Now between the parentheses here, I specify a condition which defines how long this loop will keep running. So you can read this like, while this condition here is true, I will execute the code between the curly braces. So as a condition here, I'll specify that number should be smaller than 7. Inside this loop, I'll log number and I will increase number by 1. So it is kind of like this for loop I created a couple of minutes ago, but, well, written in a different way. What do you think happens if I hit run? I get 5 and 6 because, well, currently it's 5, I print 5, it gets incremented, so it's 6, which is still smaller than 7, I print 6, it gets incremented to 7, which is no longer smaller than 7, therefore we quit the loop. So you might think, okay, that's just another way to write what we already learned. Well, that is just one example, of course. You not only can check if something is smaller than something else, but you might check some condition. And you might set condition inside this loop, well, conditionally, depending on something else. So while really is a generic loop which you can use to check any condition you might have to keep running until a condition is fulfilled or is no longer fulfilled, to be precise. So until this is no longer true. For example, if you write while true and don't execute this, you would write an infinite loop here because this will never get changed. It's always true. This loop will keep running, which certainly is not what you want. Of course, you can combine multiple control structures here. I'm setting condition to true here, and I'll use condition inside here. Next, I'll also create another variable called I, which I set to 2. And inside this condition here, I'll check if I equals 3. If this is the case, I'll set condition to false. Otherwise, I'll print I and I'll increment I thereafter. What do you think we'll get if I hit run? Well, we got 2 and 3. 2 is the starting value, of course, and then we increment it to 3, which is when we set condition to false. But we're not instantly skipping out of this loop, of course. We're just setting condition to false. We still execute this code, but then when we reach the next iteration, we again check the condition, and as it was set to false, now the loop is finished. Now, sometimes you also do have a case where your initial condition might be false right from the beginning, but you nonetheless want to execute at least one iteration of the loop. So, for example, if I set condition to false and I get rid of all the other stuff here, and I write log executed here, what do you think I'll see? Nothing, of course, because condition is set to false. But let's say condition is not hard-coded to false, but instead set through your program, and it might be true. And nonetheless, not depending on its value, you want to at least execute the code here at least once. For this case, we got another loop, the do while loop. And it's basically the while loop, but we add another keyword, do, then curly braces, and then the while condition at the end, followed by a semicolon. So we still use this while condition, but we specify that we want to execute this code anyways. So even if it is false right from the beginning. So if I now hit run, we see executed, even though the condition is false. We only see it getting executed once, but this one time is executed at least, which is what the do keyword here allows us to do. So that have been control structures, if statement, switch statement, for loop, and while loop, and how you can combine them, how you can control them with break and continue, and setting the conditions for the while loop, for example. Control structures are very important and allow you to change the flow of code execution, or also, of course, dependently execute some code, which is something you'll probably need in most of your applications.